Hello everyone. This tutorial this is the continuation of pile foundation. We are proceeding with reinforcement in piling, excluding pile cap. We haven't started any tutorial on pile cap now. So we are still on foundation, which is we are taking off quantity for pile reinforcement bar right now. So I want to show you some detail on this pile section. I want to show you some details. So now, according to this pile, this is 80 meter as the depth of the pile, 80 meter, and the reinforcement bar terminates or stops somewhere here. You understand me? Stop somewhere. But what I'm going to do now is that I want to take up for the reinforcement to stop at this point. It will terminate at this point, and it is start from this point and also terminate somewhere here. Which means the reinforcement bar is embedded inside the pile cap. Yeah, the pile cap. So before I start with the templates, I want to show you some pictures. The pictures I will also indicate. What I'm going to show you right now is one of the or part of the properties that you are going to add in the templates that I want to create right now. So let's get started with the pictures first. So this is cover. This is concrete cover. This concrete cover will be at the circumference of the stair-up or link, which will prevent the reinforcement from the heads, from the soil, so that the concrete will cover it, the beam between the reinforcement and the soil. That's the function of the concrete cover. And this concrete cover range between from 25 mm to 50 mm, depends on the design. So this is bottom bend. This is also bottom bend. So this is the ring. This is the links. This second one is the link or stair up. So what I mean by the cover, concrete cover. I used to know from this point that from this circumference of the link to this edge, at least this one will be 50 mm. If you are assume, let's say 50 mm. Good. So this is the reinforcement bar and this is the links. You first start with the reinforcement bar, then laps. This is the lap. In Nigeria here, the length of the reinforcement bar is 12 meter or 11.8. So assume that this one, okay, let me use one to explain. Assume that this one starts peak from the bottom, from the starter point of the depth of the pile, and it terminates somewhere, but it's still within the pile foundation, the pile depth. Assume that the pile depth is 30 meter. So, and 12 meter can't reach up to 30 meter. It will be within the pile. That shows that, assume that this one terminates somewhere as 12 meter. So that means that you are going to join another one, like this one now. This one is jointed. It is jointed to the one coming from the depth, from the foundation itself. So assume that this one will be joined to this one, the lap. You have to lap it. So for you to lap it now, that shows that, according to what I said earlier, the one coming from the ground, from the pile, terminates somewhere here. I'm going to add another one. That shows that the one I'm going to add will be one side lap, not two side. One side lap, and the minimum lap should be 600 mm. 600 mm minimum lap, even more than that, but minimum lap should be 600 mm. So from this point to this point, 600 mm lap. So this one is projection. We're going to add projection to to the template I'm going to create right now. So now let me zoom this one. According to what I said, at least from this reinforcement bar to the edge circumference of this circle is up to 50 or even more than 50. The way I explained the concrete cover. So now this is the projection. This projection will be embedded inside iCal, but here they didn't add any bend at the top. They didn't add any bend at the top. So this one will be embedded inside the pie cap. This one is pie cap. We don't need it for now. I'm not explaining anything about pie cap. So let's get started. Yeah. So now we want to start with file reinforcement bar. Yeah. So we are making use of count tools. So just click on count. But before we click on count, just create another folder. Just name it as file rebar. Just name it as file rebar. Just name it as file rebar. Good. For this file rebar, will be under file. Just move it like this. Press your arrow. Nice now. Okay, good. So now under this file rebar, you create another one as file reinforcement bar. So you are making use of count tools. File reinforcement bar. Yeah. So now click on advanced. If you want to, the reinforcement calculation is different from normal concrete formwork and others. Understand? So for reinforcement work or rebar, you have all your properties will be under estimating. So now just click on this and add. Just start with diameter. Just diameter. So under diameter, we have those are the 16, 20, and 22. Let's add 16 mm, 20. Let's add 22. 16, 20, 22. Yeah, okay with that. So after that, I'm done with this one. We fix the unit later. So after diameter, bar width, yeah, bar width, So bar width of 60 mm is 1.57, approximately 9. Then next one of 20 mm is 2.467 approximately. Then for 22 mm, that is 2.985. Yeah. Okay. So next one is numbers of pile points. You have to determine the numbers of pile points. Like the previous tutorial I uploaded, this one I'm not doing two different things. I'm going to focus on one. That's you're going to add numbers of points. You understand me? If it is 12 numbers or other numbers, just input it and keep moving. You understand me? So numbers of pile points. Numbers of 5 points. You can input it by yourself when you want to put it. So after these numbers of points, you have numbers of bar itself. Numbers of rebar. Yeah. Numbers of rebar. So after that, you have high depth. Pile depth. So after that, you have lab. slab. After that, you have bottom bend projection. You have bottom bend, like the one I showed you. Bottom bend. Yeah. Then projection. Yeah. So after projection, you have top bend, total length, let me rush. You have top bend, You also have total bar length, total bar length. So you also have file cap depth, and top concrete cover. So top concrete cover. So these are the top concrete cover here. So after when you are done with this property that we have listed, let me add the unit for diameter. Oh, sorry, it's mm. Sorry. So kg. Bar weight is kg. Numbers of bar. Pile depth. Slab is in meter. Then bottom bend meter. Then projection meter. Then top bend meter. Then yeah. For this, let me come back to bar weight. Just let 16 in here. So here we total bar length. To determine total bar length, okay, projection meter here. So let me first start with projection. To determine the projection, that will be pi cap depth minus concrete cover. Pi cap depth minus concrete cover. The top concrete cover you get that when we want to take off. So minus top concrete cover. So now top bench, you are just fix that one. Total bar length. So to determine total bar length, that will be pi. That's the pi depth, yes, plus slab, yeah, plus bottom bend, yeah, plus projection, okay, plus projection, yeah, plus top bend, yeah. So you can just expand it, just conclude it with brackets or round it up. You can round it up, yeah, yeah. Everything is in meter. So pi cap depth will be given, yeah, top concrete cover. Yeah. So now we are done with this. Now come down to estimating quantity formula. First of all, according to what I said or what you saw that I did, you use can't what? But you use can't to right. So just remove this takeoff. Come down to take off that bring and move. Sorry, and move this point can't. Move it. Drop it here. After dropping it here, multiply it with total bar length. Total bar length. Okay. Just drag and drop total bar length. Multiply with numbers of bar. Sorry. Just multiply it with numbers of bar. Then multiply with numbers of 5 points. Here. You now close this with a bracket. Excluding point can't. Close the bracket. So after that, you now close everything again. You can round it up, the bracket, expand this column. Now multiply it with bar width. There's a bar width here. Yeah. So the unit kg. Press enter. Turn it back. Kg. Yeah, kg. So after this, don't mind me. I'm just taking it little by little. I just want us to understand it. I don't want to rush. So now, what I'm going to click here is what that will display on the layer, so that we input the values of what we got from the drawing. So now let me start with diameter. Yeah, bar width, units, numbers of 5 years, numbers of the bar years, pile depth years, lap years, we need it. Bottom bend compulsory, projection necessary, top bend important, total pile trap depth yes important, top concrete cover important. Okay, there's something we have to remove here. Layout. You have to remove all this field stuff that I always remove. You have to remove it. Remove anything about size, just remove it. So now I'm going to group it. What I mean by going to group is that we have to create another layout for it. So for anything like bend or cover, okay, let me check it out. You have to bottom bend. So anything like bend, you have to group it aside. So just write bend it, yeah, then copy it. So you can see now this is another tab here. You have created another tab. So just paste it paste the bend there. So can you see now we have anything relating to bend, the beard, what side, what again. Yeah, we're good with that one. So now let us show the unit. Let's show or indicate the units. Yeah. Good. So now let us move, position them at the same row. Sorry. Okay. I'm okay with this one. Okay. I'm okay like this. Yes. Okay. Yeah. Good. Yeah. Let me check the form. Yeah. Okay with this. Yeah. Okay. So now we can move it under. You can move this file reinforcement bar under the file folder. Again, yeah, can you see now? It's embedded inside it. So come back to home, open it, expand it, expand it. So now, what do we need? I need to know it now. For pile 600 mm diameter, we have depth is 80 meter and number is 33. Okay, diameter. Okay, what's the quantity? For 600 mm diameter, we have 10 numbers of 60 mm diameter bar, right? Okay, for 500 mm diameter, we have 8 numbers. So hope we get this. That's what I said. So yeah, top cover. Let us use the top cover. Just use from here to there. Just look at 200. Let us use 200 mm for the top cover. First one from the top cover. So we are going to uncheck this one. Projection. Don't need to show it. Don't need to show it. Yeah, don't need to indicate it. Yeah. Remove it here. Remove the projection. Yeah. Remove the projection. Remove the projection. Click on OK. Come back to home. Let's come back to home. So I want to show you guys this. The depth. Okay, for this 1 mm diameter, the depth is 18 meter. Likewise, 500 mm diameter. Quantity of this is 33. Of this is 38. So now, in situation whereby the reinforcement start from this point and terminate somewhere here. So we are going to take off for the reinforcement bar starting from this point and stop somewhere. So now this is 18 meter. The diameter, the reinforcement diameter for this for this orange 600 diameter is, sorry, I'm mixing it up. The reinforcement bar for 600 mm diameter pile is, we have 10 numbers of 16 mm, and for this 500 mm diameter we have 8 numbers of 16 mm. Try to grab it. Then we are going to take something to consideration. The cover from here to the top cover, just make use of 200. Then what else? 200. That is all. 12 mix of 200. So let's come back to here. Just name it as pile reinforcement bar at 600 mm diameter. So if the diameter is, the reinforcement bar is 16 mm, yes, is the bar width, and numbers of 5 points. We have 33. Numbers of the bar, you have 10 numbers. Pile itself, pile depth is 18 meter. But I'm not going to make it of 18 meter because at the bottom of the pile there's be a cover. Like just use like 100 mm. Just use like 100 mm. That will be 17.9. Lab, something is of 600, and the way I explain. Then pi cap is 1000 to 1.2. I will still show you. It's 1000 to 1.2. Then top concrete cover, according to where I explained, I'm making use of 200 mm. So bottom bend, since the diameter is 600, and that 600, that is not the area that the link or stereo will cover. I'm going to reduce it to 50 mm. You understand? 50 mm. That shows that I'm going to make use of our bottom bend. You can make use of like 150. It's still okay. 150, 0.15. Then the top bend, you can also make use of 150. Depending on your choice, you can increase it to 200 or 300, anyone you like. You can increase by yourself, depending on choice. So now, click OK. Make sure that it's one click, because I've already fixing the total numbers of the reinforcement bar we need. I mean the total points of the pile that we need. So just single click. Something is wrong somewhere, but let's just check it. Can you see now? I know something is wrong. Just go down. Just go down. I need it. Advanced. Just come down to that you have 10,000 something kg here. So let's come down to takeoff. You have to remove this one. You have to remove it. You have to remove it. Come down to quantity, drag, and come and drop it. And come and drop it here, and change the unit to kg. You see that everything will work out smoothly. Can you see now? So I have to update the templates. I have to update it. So you have 10,421.4 kg. Just come back to templates. Just come back to templates, and so repeat what I did to take up data. Erase this. Some of you think this thing is not easy to just create. Sometimes you think that I forgot some things to insert or something like that. It's not easy, but once I discover that something is wrong somewhere, I'm able to understand myself that I have to adjust something from other. You understand me? So it's not easy to just create a template like that. First of all, you have to settle down, draft it, understand what you've done manually, relating it to Planswift software. So after that, we now come down to the software and perform the magic. You understand me? So change this one to kg. Change this one to kg. So you're good to go now. The next one is link or stereo. You're also making use of count tools. So just limit as file, stereo or link, anyone you like. Stereo, click on advanced. I'm coming back to them. So let us focus on the property. Diameter. Next is bar weight. Next is bar weight. Then next one is center to center. center to center, center to center. Yeah. First of all, this diameter. Mm. Bar weight of 10 mm is 10 mm, 10 mm 617, yeah, approximately 10 mm. 0.889 is 12 mm, yeah. Okay, good. It has been specified in the drawing that is 10 mm as the stirrup. Yeah. It has been specified. So center to center. After center to center, you also add stirrup length. Stirrup length. Yeah, after stirrup length, you're going to add total stirrup length. Total stirrup length. After that, lap. After lap, file rebar length. Sorry. File rebar length. After that, file depth. So after that, projection. After projection, stirrup number. Yeah, stirrup numbers. Then numbers of 5 points. Numbers of 5 points. Yeah. So now let us create the formula. Center to center. How can you determine? So for center to center now, you can just activate it now. Like input 0.15 and the spacing or 0.200, or let me use order instead. Also use order 0.10. Yeah. So you can select anyone. Stirrup length. So stirrup length. This stirrup length, I don't want to determine by ourselves. I will show you guys. How to determine the stirrup length. Just keep calm. So total stirrup length. The total stirrup length will be stirrup length plus what is lap? Plus lap. That is total stirrup length per 1. Per 1. So now, what is projection? So to get the projection, that will be pi cap. But you didn't add pi cap. Yeah, that's the pi cap minus top concrete cover. So that's what I'm going to do now. So I'm going to add pi cap to our property. File app and top concrete cover. Very add it here. Yeah. Top concrete cover. So now, so the next thing according to what I said is the projection. Our projection is pi cap minus top concrete cover. Yeah. So the next one is pile rebar length. Pile rebar length, to determine the pile rebar length, that is the pile depth plus projection. Yeah. The next one is stirrup numbers. To determine the stirrup number, that is the pile rebar length plus projection. Yes, that is how to determine the stirrup numbers. That will be, I'm coming. Stirrup numbers, that will be pile rebar length plus projection divided by, we now close the brackets. That we've added the two together, pile rebar length. You understand me? How do you get the pile rebar length? That is pile depth plus projection. You understand? And the projection, if we deduct the cover from the pile cap itself. So pile rebar length plus projection. Yeah, get it? Pile rebar length. No, you have mixed it up. No, because this pile rebar length itself. So when creating this template, that to calm down. You understand? So this, to determine the stirrup numbers now, I said this pile rebar length. Let us check how this pile rebar length is being derived. That is pile depth plus the projection. You understand me? That shows that this one now will be pile rebar length. You already know the total length. Divided by what? Divided by center to center. You understand? Divided by center to center. You understand me now? Pile rebar length. This pile rebar length, we've added two things together to determine the total length. You understand me? To determine this total length. So after that one, now divided by center to center. So the next one is, what is this? Numbers of 5 points. Stirrup numbers, and numbers of 5 points. Determine that one. Then pie cap, yes, pie cap cover. Pie cap, yes, slab, yes. Stirrup length, yes, we determine that one. Yeah, okay, good. So let us check or fix the units. Diameter is in meter. Bar width, kg. Center to center is in meter. Then stirrup length is in meter. Total stirrup length is in meter. Slab is in meter. Fiber meter. Depth meter. Projection meter. Stirrup numbers. No, it's not a meter. Numbers of 5 points. Pie cap is a meter. Cover. Yeah. Before I forgot this one now, let me first remove this one. Let me come back to this. No, I have any mistake again. kg. So drag and drop the quantity. Yeah. So now I want to double check. I don't want any issue with this. That's why we not say someone will not come back at my comment section box that, oh, you mix it up, something like that. So now diameter 10 mm. I mean 10, yeah, no meter is mm. That's why you have to double check anything you do. So 10 mm, bar with gauge. There's kg of 10 mm is 0.61 semi approximate. Then center to center. Let's use 150 to stair up length. That is for the stair up length. We're going to determine that one by ourselves. I will explain. Then total stair up length. That will be stair up length plus lap will be given. Not that sometimes structural engineer will be given, but structural engineer, but sometimes I don't want to add it. So now pile rebar length. To determine our pile rebar length, that will be pile depth plus projection. What is the projection? Just come down here. Good. Projection is pile cap. Hope you understand what I mean by projection. I show you guys somewhere here. This is the projection. This is the projection. So projection. Where am I? Yeah, projection is pile cap minus top concrete cover. This is the top concrete cover. We use 200 for the top concrete cover. We use 200. So that is for the projection, the pile cap minus top concrete cover. Top concrete cover. So now after that one, this is where I am. Okay, that's how we got the projection. The pile depth. For the pile depth, we will give you the detail. That is 80 meter. Projection. What is projection? I've already explained that one. Stair up numbers. To determine the total stair up number, that will be pile rebar length. You understand me? Pile rebar length divided by the center to center. Give us the desired numbers or actual numbers of stair that we need. So now numbers of 5 points. You fix that one. You have 33 and 38. Pile cap. Yeah, okay. Let me edit it to pile cap depth. Okay. Can you see that has changed depth? So now oh no, can't move anything. Let me just check it. Diameter to show bar, center to center, stair up length. You have to show it on the form layers. Then what else? Total stair up length. No, don't need it. Lap important. What of pile balance? No. Pile depth, very important. Then projection, no. Stair up number, no. Numbers of 5 points, very important. Then pile cap depth, necessary. Top concrete cover, good. So let us come down to all these that we always remove. All this field, you don't need it. The by chart. They're not important for us to use. So let us come down to form layout. Let us show the unit first of all. Let us show the units. Show the unit. So do you have anything to group here? Depth. You don't need to group anything. So now just bring it same row. Shape. Okay, click on okay. We're good to go. Click on form. Let's check it. Input diameter, input the bar width, offsets. Center, stair up length. Yes. Lap. Yes. Depth. Yes. Numbers of 5 points. Pile cap depth. Top complete cover. Okay. So click on home. But before you start anything, according to what I said, you have to determine the setup length by yourself. The type 1, let me show you. For type 1, you have 600 mm diameter, you also have 500 mm diameter. So we're going to work on the same. So now let us first work on takeoff for 600 mm and then 500 mm diameter. So to draw the circle, hope you still remember where I explained this thing to you. So first click on this point, press space down, input 0.6 as a diameter, then 0.6, oh sorry, not 0.6, I'm coming. First input the radius, yes, down, click on down arrow, 0.3, and left side 0.3, then right side 0.3, then down 0.3, 0.3. Yeah, so for us to draw the circle now, escape the diameter and the dimension, click on anything here. Don't name it, just okay. You can name it or you can leave it just to get the circle. Make sure that this record mode is at point to point. First click on this point, click on A to give you the arc, this point, then click on A again, and then around that, click on escape. So now we are good with this one, we're good to go. So now what I'm going to do now is just delete all this dimension. To reconfirm, can you see 600? 600. No, so now, according to what I said, based on the setup, I said let us use concrete cover as side concrete cover as 15 mm, right? So now what I'm going to do now is that click on dimension, bring your dimension up and press up arrow, input 0 and point 0.0, 0.05. Yeah, same thing to all sides, and right arrow 0.05, same here, down arrow 0.05, then left arrow 0.05. Yeah, what next? Escape. So just click on another linear to click on OK. Click on this point again, press A to give you the arc. Oh, okay. Oh, I made a mistake. There's a mistake here. So this thing, you have to be patient. According to what I said, you want to add cover. So if you want to add cover, that should be, the offset should be inside, not outside. It should be in, not outside. So now we can move it. Press M and Shift Alt. Sorry, just delete it. So all these things, just to be patient. So now let me start again. Click on this down, that is 0.05. Yes, and 0.5 again, up 0.05 again. Yeah, 0.05. Yeah, good. So now click on your name here. You can name it or anyone you like. Click on this. Click on A on your keyboard, which was Alt. Then A again. Yeah. So now delete all the dimension. Now. So now, what is the length of this one now? This is 1.88. Out of this, 1.57, the length of the one you need. You understand me now? So now, for the stirrup length, is now what, 1.57. Yeah. So according to the lab that I explained for the main rebar, I said, for example, if this stirrup is being deformed, starting from this point, now around like this, and terminating. For you to add the lab, that's why as this one is coming, you can just bring it, adjust it, and just stop somewhere here. Or anywhere, somewhere here. It depends on the length of the lap. So now, first of all, you are done with the stirrup length, which you have 1.57. So for the lap now, you can add 200, or it depends on your choice. You can add 200 or anyone you like, or more than that. So let's get started. So let me work on this one is from 600 diameter, right? So let me work on the 500 mm diameter. So I want to confirm something. Good. I just want to confirm. So now, since we've deducted 50 from here, it will give us 500. You understand? What I'm going to do now is that, thank God, just copy this one. Let's shift Alt. Just okay. Sorry. If you want to copy it, very simple. I'm coming. This person shift Alt, then move it. It's just to move. Just copy it. Come down and click on copy, and then paste it. Paste sections into a new item. The color has changed, so you can move it. Press shift Alt, then move your mouse. Move it somewhere. You understand? So just hide this one, or delete it, anyone you like. So now let me redimension. This is 500. So now for to create the stirrup for this 500 diameter now, that will be same procedure with this one. Click on this, press down, 0.05 up, 0.05 right, 0.05 left, 0.05. So now what next? You know what to do. Click on this, press A on your keyboard, then A again on your keyboard. Yeah. So now this one should give us 400. Can you see now? 400. Oh, you know what I did now. This is 400 now. So let me just what's the length for this one? For the stirrup of this 1.26. This one is, let me show the legend. So I need to see clearly. Show label. Sorry. Why is it so big like this? and it. So now, so let us keep moving. We don't want to waste our time. So stir up at 600 mm diameter. The length is 10 mm. So this is the bar weight. That data is 150. But just reconfirm. I don't want us to guess. It's 10 mm. That data is 150. Nice. Okay, let me just show it. Show you there. The first one is 1 point. For this one is 1.57, right? So now to activate the formula, to activate the estimate the quantity formula now, that will be you have to bring and drag and drop the pile point, the point count. Yeah, drop it, then multiply it with the total stir-up length. After that, now multiply again with stir-up numbers. Then multiply it again with numbers of 5 points. But before you multiply, let us first close this on the bracket. Then after that, you now close this one again. You can round it up here. Then after that, you now multiply it with bar weight. And this one is in kg. Click OK. Come back to home. Now come back. Okay. Come back to home. Click on OK. Let us name it as at 600 mm diameter. This diameter of the reinforcement bar. This is the bar weight. This is the step center. Stir-up length, because this one is 1.57. The lap, now this is 200. Pile depth, I don't know what I said, there will be a cover at the bottom of the pile. So the depth is 80 meter. 100 minus 80 meter, 17.9. The numbers of pile points. This is the numbers of pile points. You have 33 for this diameter. Out of pile cap depth, 1.2. Concrete cover, 0.2. Okay. Making kill 1 point. So the quantity you get is 4,541.1 kg. So this is how to measure or derive the quantities for stir-up. So let me take up for the second one. Let's just hide this one. Okay, I can leave it. Let me hide this one. So for this, we have 1.26. at 500 mm diameter. Same thing here. Yeah. Stirrup length 1.26. The lap using 200. Depth 17.9. Then numbers of 5.38 for this one. Pie cap is 1.2. So top concrete cover using 200. You can change this one to maybe a square. Just click on one point here. So this one quantity for the stirrup at 500 mm diameter is 4,313.4 kg. You know that the length is different. This one is 1.26. The first one is 1.57. So there's a little difference in the length. So this is how to take off for pile reinforcement bar, the projection, the lap, then the stirrup and the main bar. Thanks for watching, and if there's anyone you didn't understand, please feel free to chat me up on the comment section box. Thanks for watching.